Yeah, I'm recording already, but
it's okay. We can always edit out. By the way, you'll know because the red light's on. Okay, so everybody, when the red light's on, we're recording.
Cool.
Okay.
Hello, my name is Kimberly Zai, and today I'm going to talk about sensors. Now, sensors can be found everywhere in life, and they can range from something as simple as a thermometer to something as complex as a fingerprint scanner. And now, so the question is, what exactly is a sensor? A sensor is basically a device that is able to convert a physical parameter to an output. This usually takes the form of an electrical signal, or it can be a visual sign. They're also commonly referred to as transducers because they're able to convert energy from one form to another, like converting a physical thing to an electrical signal. Now, in everyday life, sensors are typically used in feedback control loops. So what happens is a process might be going on, and a sensor will take the measurement of it. And it will relay that information to a machine or a human, and they will have the decision to either stay with the current information or to make an adjustment in the system. And if they do make an adjustment, the feedback control loop starts over again with the process as it is disturbed, and the sensor will continue to take a measurement of it. And I'm going to talk about now 5 basic types of sensors. I'm going to start with a mechanical sensor, then I'll go to thermal, electrical, magnetic, and chemical ones. As you can see, they can get pretty complex, like the one with the thermal image of a horse. Now, one type of mechanical sensor is the piezoelectric accelerator. How it works is it's based on the piezoelectric effect, which basically says that a certain material, when a mechanical stress is applied to a certain material, these materials can be like certain types of ceramics or crystals, it will actually create an electric charge. So when this sensor is has some acceleration applied to it, a mass of unknown weight will accelerate along with it, and that will cause a force to be produced to be put on the piezoelectric material. And when that happens, an electric charge will accumulate. This electric charge is proportional to the acceleration in the mass. Now onto thermal sensors. One type is a thermocouple. How it works is it's based on Seebeck's effect. This says that a conductor will generate some voltage if there's a difference in temperature around it. In this picture, there are 2 different types of metals, A and B, and they will both generate a different kind of voltage depending on the temperature. And so the thermocouple will actually measure the difference in this voltage, and because of that, it only measures the difference. You actually have to have a reference temperature. So the ice bath is a reference temperature, and it will actually help you measure the actual one. Moving on to electrical sensors, one is called the moving coil galvanometer. What it does is it actually measures the amount of current going through in a wire. And it works because when current runs through the coil, it will actually have a magnetic force produced onto the coil, which will end up rotating it slightly, and the needle will move along with it. A spring is able to move the needle back to the equilibrium position, and that's how it restarts. And now onto magnetic sensors, as I was talking about magnetic fields before. There's something called a scalar magnetometer. So it works basically because of Hall's effect. This says that when a conductor is in a magnetic field and a current runs through, it will actually make a voltage difference. So the magnetometer is able to measure the shift in current, and that will end up producing, help it determine the strength of the magnetic field. So my next one is going to be about chemical sensors, and the one I'm going to talk about is the fuel cell breathalyzer, which is cool because we learned about fuel cells during camp. So how this one works is it's able to measure the BAC, blood alcohol level, in a person by first oxidizing the alcohol in one breath. This will produce acetic acid, protons, and electrons. The electrons will travel to the wire, making an electrical current that will help the breathalyzer work. And then it will combine with the protons, electrons, and oxygens at the end and produce water. So the only actual product of this is water. So as you can see, the sensors are everywhere in society. You can find accelerometers and magnetometers in a phone. It helps you determine where you are and how it's moving. You can also find a magnetometer in a metal detector, and a thermocouple, and a thermostat. So in order to have sensors, there has to be a lot of math and science behind it. So I decided to choose one mathematician here of Alexandria and one scientist, Helmholtz, to talk about today. Both of them have made significant contributions to society and have been able to affect it. So does anyone recognize this equation? Raise their hand. What is it?
It's Hero's formula for determining the area of a triangle.
That is
That's fine.
exactly correct. Good job. So yeah, this is just one of those many famous equations here that Alexander was able to develop during this time. He was a Greek mathematician and engineer, and he lived from 10 to 70 AD. He actually worked at the Museum, which also included the famous Library of Alexandria. He was a professor there, and he actually wrote many manuscripts on the work he did. So by looking at all these manuscripts, we were able to discover some of his most famous inventions. He invented the first recorded steam engine, the first wind-powered machine, the first vending machine, and he was also able to invent fire-activated temple doors and a fountain that was named after him, Heron's Fountain. How the Elo pile works is that fire is ignited beneath the cauldron of water, and the water will heat up. The water will thus turn into steam, and it will travel out through bent pipes around a ball, causing it to rotate. And how the first wind-powered machine worked was it actually powered an organ. What would happen is wind would rush by and rotate fan blades. And on the other end of the shaft, some pegs would rotate too. The pegs would lift up a piston, which would draw in air, and when it passed by, in that interval where no peg was on it, the piston would fall back down and compress air. This compressed air would then blow through the organ, causing it to make sound. So yeah, it was able to actually create a lot of different sounds. Of course, it wasn't controlled because of the compressed air. So now onto the first vending machine. So people would just go to church and they would drop a coin in at the top. It would fall onto a lever, R, which would lift the other side of it and open this spout, a plug, and holy water would issue forth. Now here it didn't stop just with a holy water dispenser for church inventions. He decided to make fire-activated temple doors. So how this worked was, first of all, you would have to fill the globe halfway up with water, and to open the doors, you would light the altar with fire. This would end up creating the air pressure inside the altar and the globe to increase. And once that happened, then the water inside the globe would travel into the vessel, the weight of it would pull it down and activate this pulley system that would turn the hinges of the door, helping it open. And to close it, you would extinguish the fire, the air pressure would drop in both the altar and the globe, and the water would flow back from the vessel into the globe, and a counterweight would pull the doors shut. So the next thing he did was Heron's Fountain. How this one worked is it was all powered by air pressure, so the connections between each of the three basins would have to be airtight. And the precondition for this one is that the middle basin would have to be filled up completely with water. How you would get it to work is you would pour in water into the top basin, it would flow into the bottom one. This would cause the air from the bottom basin to flow into the middle basin, which would push the water from the middle basin into the top basin and power the fountain. People constantly used to think it was a perpetual motion machine, but it wasn't, as you can tell, because eventually the water level would fill up the bottom basin. Although he made a lot of inventions, he was also known for his advances in optics. He had created a principle of reflection, which ended up leading to Fermat's principle, which led to the beloved Snell's law we all know today. So as you can see, he's had many impacts. Steam turbines and windmills are used today to power electricity, and the vending machine, you can find it anywhere. And even in middle schools today, I know, at least for me, I learned Heron's formula before. Now going on to Helmholtz, he also made significant contributions to science. He was a German physicist who lived from 1821 to 1894. He's known for his advances in waves and optics, especially his theories for color vision. Now during his time, there are actually two different kinds of philosophies. Natural philosophy, which was developed by Friedrich Schelling, and vitalism. Natural philosophy stated that the spirit actually had an effect on nature, and vitalism stated that there is actually a vital kind of unknown force that acted on all organisms. Now, Helmholtz was able to reject these theories and state, you can actually find where the source of energy comes from for everything. So he ended up being one of the contributors to the conservation of energy. Other scientists also developed this. And he ended up expanding his knowledge to the Helmholtz free energy equation. It's able to find out the amount of work you can do in a closed thermodynamic system under constant volume and pressure, or temperature, under constant volume and temperature. Another time he was able to divide preconceived notions is determining the nerve impulse speed. In In the past, people thought it was impossible to measure the speed of a nerve because it was too fast, but he was actually able to discover that it only went from 24.6 to 38.4 meters a second inside a frog's muscle. He expanded on his achievements by the Helmholtz equation. It's able to model the behavior of a wave. So this is exactly the behavioral wave equation, and it ends up looking pretty much like his formula. And if you've ever blown across the top of a Coke bottle and heard a sound, you've been experiencing what Helmholtz has discovered as Helmholtz resonance. He was able to explain this by stating that if you blew across the neck of a bottle, you would actually compress the air in it a slight bit. This would raise the pressure inside the Coke bottle and cause it to drive the air inside the neck slightly up. And in turn, this would cause the pressure to decrease in the Coke bottle again, and it would drive back and forth, and it would create an oscillation that would end up creating resonance. This is kind of like a mass spring scale where it oscillates. He expanded on this by creating Helmholtz resonators. How it worked is it would hear multiple sounds, but it would be able to isolate one frequency and actually amplify it. So he was able to design different kind of resonators that would help different frequencies based on that equation. And one more invention he did was the Helmholtz coils. He was actually able to create a relatively uniform magnetic field between these two coils by separating them apart the same amount as their radius. So that's how they work. And then he started turning to optics, and he actually invented the ophthalmoscope. It's still used today in eye examinations. It kind of looks familiar, doesn't it? And it's used to check the fundus of the eye. And the fundus means the interior surface of the eye. Now, this is one of his most major contributions to science, the young Helmholtz theory. He actually was able to discover that the eye has 3 photoreceptors, red, blue, and green, that help the brain interpret colors. Blue corresponds to short wavelengths, green is middle wavelengths, and red is longer wavelengths. And as you can see, Helmholtz has impacted us today. With his series in color vision, we're able to understand optical illusions better, and Helmholtz resonators are able to help loudspeakers amplify certain frequencies, and they tend to amplify the bass. Thank you.